Assalamualaikum and good day. Today I'm going to prepare a video on content which is related to testing. Okay, it's on testing throughout the software development lifecycle. Okay, this is the content of the video. Okay, we start off with software development lifecycle model. Okay, this is more like a review to you. If you still remember, there are actually many software development models. Okay, the more traditional one is sequential models, waterfall models, V models. I hope that you still remember these models. And the new ones are having interactive and incremental characteristics. And they are basically from the Agile method. There are various. Among the famous and the common one used is called Scrum, XP, Kanban, DSDM, FDD, and Crystal. Okay, so this is to recap what waterfall model is, right? It's like waterfall, meaning that you have to do one at a time. After you finish one phase, then you move on, and there is no way to fall back to the previous phases, right? So you do requirement definition, and then you do analysis and design, coding, and then you start after there is program already, you start to do testing, and then it's ready to be implemented, and then after that it's ready and the user is using it, and the next phase is maintenance. Okay, you have to maintain it. Okay, V model is like V shape, yeah, it's still actually similar like waterfall. It's just that at every phases there is testing, meaning that when you do system requirement during the early phase, okay, you start to write test cases for acceptance testing already. Okay, and then when you have high level design, like you have your UML diagram, okay, you can start writing your system test cases already. And then when you start coming up with your sequence diagram, class diagram, that is where you are doing low level design. Okay, at this point of time, you already have information that you can use to write your integration testing test cases. Okay, and then you have when you are ready to do coding, so you are having enough information for you to do your unit test. Okay, so this is the system development life cycle phases, and this is the phases related to testing. Okay, so at every phases, you are actually deriving the test cases already. Okay, what is the characteristics of good testing? Okay, every development activity has corresponding testing activity. I think that is what V model is trying to do. And at each test level, it has its own test objective, okay, suitable for that level. And right, so you begin testing when you are developing. So you have to, if you are doing V model, you should have your developer and tester ready at the same time. Okay, not like waterfall. You do testing only after you have your code, maybe during the fourth phase and fifth phase already. Okay, tester participate in discussion. Okay, so you have your tester also participating in a discussion to refine the requirement and design. Okay, because if we are using waterfall model, tester only come after they are doing testing. But in V model, it's actually the tester get involved earlier at every phase, so they can give feedback straight away. Okay, so the earlier model, the current model that most of the software developer are using right now, if they are applying agile approach, is called interactive and incremental model. So using this kind of approach, what will happen is that they will have small cycle. Okay, So they have a series of smaller repetition. So one cycle, they will come up with a small version of running software. Okay? So they will keep on adding during the third cycle, fourth cycle, they will keep on adding more functions. So this is a newer version of software development life cycle, which is using agile approach. Okay, this is a more realistic approach nowadays, and at every cycle or at every iteration, it's followed by testing. Okay? So meaning that after one iteration, so software, several function of running software is already available, and these running functions are being tested. So it involves tester and end user more, okay, because they are involved in every repetition. Okay, right. So this is what I mentioned just now. For every iteration or every cycle, they will do analysis, design, coding, and testing. If for several use cases or several functions, okay, so they will select, they will prioritize the user story. It's like you can imagine it's like your use cases. Okay, so they will rank the user story according to the priority, and they will choose one or two, and then it will go through analysis, design, coding phase, right? Maybe 2 to 4 weeks for one iteration, and the system is ready. Not the system, the user story is ready, and then it is tested, and it is actually runnable. And then for the next iteration, they will choose another user story and do the same process. Okay, that's agile method. Just to recap, for those who have, I think you have heard about agile before. Okay, the concern of agile method, these are the basic principle if you are applying agile software development. Okay, they are more concerned on individual and interactions. Okay, they are concerned with the user's interaction, the member interaction, okay, over process and tools. They are more concerned on the working software, right? I say to you, every one cycle, there is a working software already, and they are not too much of concern on the documentation part. And then they are very focused on customer collaboration. The users are involved in every iteration, and responding to change is their focus, because the user are there. So once the user see the first iteration, uh, if they want to do any changes, the changes are done in the next iteration straight away. Okay, there are actually agile method. There are underneath it. There are many approaches: Scrum, XP, and so on. The most common one is Scrum. Right. Okay, let's move on to the next content, which is on test levels. Okay, so when you are doing testing, there are actually many levels. Okay, not necessarily you do it when the system is ready. You can do it when you are still having classes at class level or module levels. Okay, component testing. Okay, component testing are done at component or units. If you are developing in Java, maybe you do it at class level. Okay, it can be done in isolation. Okay, when you are doing component testing, you can actually use the component specification in order to help you to write your test cases. And you normally do component testing at the development environment, meaning that it is done at the developer side, and it involves the programmer. Okay, the programmer are the one that write the codes, and normally you And normally at this point of time, it involves the programmer. It is also known as unit, module, or program testing. It has different names. Okay, the second level is integration testing. Okay, this is where you have several components already available and you are trying to connect to one another, and the goal of integration testing is to expose faults in the interfaces. Okay, so because there are several units or classes already there, and we want to test whether they can be connected through the interface, and we want to see how the interactions happen between the component, and you want to find the possible faults that might happen. Okay, component integration testing. Okay, just now we look at integration testing, and okay, we'll look at the component. Let's move it here. Okay, just now is a component. This is integration testing. Okay, let's see where it can happen. Okay, so we have component testing just now, right? So when there are several components already available and we are integrating it, so the next phase is actually to do the integration testing, and then there is one called system integration testing that happen after you have done system testing. Okay, just now I was explaining about integration testing, and then when several components are already available, you combine them together to make it as a system, and then you do system testing. And if this is a large system, maybe there are another set of system available at the same time to handle different parts of the system. I mean, if you have another component, another system to handle different portion of your bigger system, they will be available. You have to do the system testing as well. And then system integration testing is where you actually integrate several systems together. Okay, and after that you do acceptance testing. Okay, there are several strategies on how to do this. We call Big Bang and Incremental. Big Bang is where you combine all the components together and you run it and you test it at the same time. So it saves time, but there is a risk of late defect discovery. And when the error happen, you don't know. It's slightly harder to find where the origin of the error. Okay. Okay, that is Big Bang, right? Big Bang. The other one is called incremental. Okay, incremental is where you combine the components bit by bit. Okay, right? It's like you play a puzzle, so that's how you can imagine it. Right, and you add one by one, and when you do that, it's easy to locate and to fix the defects. And to do this, there are several strategies. It's called top down, bottom up, and functional incremental. Okay, top down is where it's like this. It's like you have the component, you test the component first, and then if this component one needs another component, so it will test it like that. Okay, and let's say when you are testing component 4 and the other component that is needed is not there, you will have to write a stub. What is stub? Stub is actually a program, a temporary program, which is not actually working. It's only normally it's a dummy program where, for example, if you write the code in Java, it will have the method name, but maybe inside the method, there is nothing happening. Maybe it's only printing something. Okay, so it's there just for the sake of making the system runnable. Okay, that is called stub. Okay, you use stub when you do top-down integration. So the second approach for incremental testing during integration testing is called bottom up. Okay, bottom up is like this, where you have uh, a component at the lower level, okay, you test it at the component at the slightly higher level, right? So let's say when you test one component, the slightly higher level component is not ready, so you create a driver. Driver is like your main program. Remember when you write your Java program, you have main program, right? That is the program that is used to run the program. So the same case with bottom-up integration. You need a driver, a program, a temporary program that is used when the calling program is not ready. Okay, so driver is like the calling program, and sometimes it is called test harness or scaffolding. Okay, component at a level integration and testing before moving to the level above. Okay, so you test the lower level class first before moving up. Okay, the third strategy is called functional incremental. So what happened here is that you combine several components together. You combine the components that is needed to achieve a basic functionality. Maybe you have one function and then there are several other functions more, but you choose one function first, and then you identify the classes, for example, that is needed to make the function runnable, and you test it. Okay, sometimes this is called thread testing. It's like this. Maybe there are several classes already available, but you don't test them as a whole. You test it based on their function. So, for example, one function of a system needed these classes, so you test them together. Alright. So when there is another function that you want to test, you select the classes that is involved and you run it. Okay, now that you have done the integration testing, right, you can do system testing. System testing is where you test the system as a whole, okay, as defined by the scope of the development project. Okay, when you test it, it must be run in the test environment which will be used in the final production environment. What that means is that you need to replicate the environment that will be used by your user later on. Okay, so that you run it at the almost the same capacity that your user is using. For example, they are using certain you need to identify the server specification that they are running, the kind of laptop specification. You have to identify the normal machine, the laptop specification that your user are using. So you try to replicate as though you are running it at your user side. So normally this is done by the independent test team. Okay, so it's not done by the programmer. Normally it's done by independent test team. So when you do system test, these are the documents that you normally refer to. Okay, requirement documentation, system specification, because you want, and then business processes. Okay, what are the business processes that is important for your user? Okay, you will refer back to your use cases or your user story. You use user story if you use Agile method, and description of the system behavior. Right? And then after you have done system testing, the next one is called acceptance testing. So this is done by the customer or the user of the system. It's no longer done by the developer team. Right? So the objective is to establish confidence. You want to make the user feel confidence about the system. You want to assess the system readiness. You want to see how good your system is when it is being deployed and being used. At this point of time, the focus is more on getting the business related cases right. Okay, not to find defects anymore. Okay, so finding defects are done earlier. Okay, there are several types of acceptance testing. So you don't do all. It depends on the agreement that you have done with your user. Okay, what do they want you to perform during acceptance testing? All right, let's have a look. The first one, user acceptance testing. Okay, it's done by the user, typically focusing on validating the fitness for use of the system. Okay, to build confidence of the user. Right, so that's the purpose. The second type of acceptance testing, which is called operational acceptance testing. So this is done by the system administrator of the user. Okay, they are more focusing on how far the system handle backups and restoration, how does it handle installation, uninstallation, and upgrading. Okay, how far your system actually handle this disaster recovery, user management. Okay, how to add users, how to remove users, how to do maintenance, uh, how does it handle security aspect. Okay, so it's more on the system administrator sides, and their focus. And then the third type of exceptional acceptance testing is called contract or regulation acceptance testing. So this all depends on how far the user want you to do the test. Okay, so if you have certain uh, agreement in your contract that you have decided earlier, so you have to perform the acceptance testing against the contract acceptance criteria for producing custom developed software, or maybe some of your system that needed by the user is to follow certain regulation, so you have to make sure that you perform that testing related to the regulation agreed by the user. Okay, and I think you have heard about alpha and beta. Okay, alpha and beta refers to when you do alpha testing, it's actually you call the user to come to the development office, and you ask them to perform the testing at the developer side, whereby when you do beta testing, you actually the testing is done at the user's place, at their own machine, at their own laptop. That is called beta testing. And normally you do both when you are when the user buy commercial off the shelf software. Okay, to get their feedback. All right, so let's look at different types of testing. Okay, so I think you have heard about functional testing, non-functional testing, whiteboard testing, and change-related testing. Okay, all these type of testing can be done at different levels. What that means is that, let's say you are doing component testing, okay, at the early phase, where there not much classes or modules are ready, you can perform functional testing, non-functional testing, whiteboard testing, and change-related testing at the same time. So it depends on the rigorousness of your testing. It depends on what has been planned by the test manager. And you can do that in different level of testing. Okay, when you do acceptance testing, you can also do functional testing again, non-functional testing, whiteboard, change. So it depends on what has been planned. Alright, functional testing, I think you know it very well. So it's basically to test what the system does. Okay, you are testing the functionality of the system. And you can also do non-functional testing. Okay, so basically concern about how the system works. You want to see the performance, you want to see the usability, okay, how well you design it for the user. You want to see how reliable your system is, portable, whether your system can run in different platform. You want to see the security aspects and also the compatibility of the testing. So that is on non-functional testing. And then different types also refers to whiteboard testing. So whiteboard testing is more concerned just on the code. You want to test the internal structure of the code. You want to see how the flow of the system, okay, how the data is being used and how it changed from one module to another module. And it requires very technical aspects, okay, because it's look at how the data will be stored, what kind of coverage tools that you want to use, and how to, because at this point of time you have the data will be a lot, the test result will be a lot, so you have to have some skills to interpret the results. Okay, there's also another one which is called change related testing. So this is concerned about the changes that might be done throughout the testing. Okay, remember sometimes when you do testing, the tester will find defects, right? The error. So, and then you will send it back to the programmer to fix it. And confirmation testing is about checking whether the defects detected earlier has been solved, has been removed. Okay, there's another one which is called regression. Regression is done when software is changed or the environment is changed. Okay, it's done to discover any unintended defects introduced as a result of changes. Let's say, remember when you do testing, the tester found a defect, several defects, and then the programmer is will handle all the, will try to correct the defect, and then when you test it again, you don't want to discover other defects. Okay, so that is the purpose of doing regression. You don't want to, you don't want the newly changed program to trigger other defects. Okay, the regression testing is aimed at verifying that all the unchanged part of systems still function correctly after the implementation of a change. Okay, let's see, a visual representation of confirmation and regression testing. Okay, let's say when the tester check the system, okay, let's say it found a defect from module D, and this module D actually call other modules, module C and B, right? And then the programmer, the defects are reported, and the programmer try to remove it. They will do changes on the code, and then after it is being fixed, okay, you run confirmation testing, right? And then after that, you found no more defects from module D. You have to check whether module C and module B are not affected with the new changes. So when you check module C and B, you are actually doing regression testing. Okay, the last one, which is called maintenance testing. Alright, so maintenance testing is done where the system is already running at the user side. Okay, this being already deployed at the user side. So as the user use it, they are getting more familiar with it. So maybe along the way, they want modification to the system because they want new functions, or maybe they move from one, they move to another platform that requires system migration, and then maybe they want to do data migration. Okay, they move to different database, or they want to use more data, so that involve a system retirement. Okay, modification to an operational system include plan enhancement changes. Okay, sometimes they want a new version. Okay, they plan it earlier, so they want, okay, second version to have new functions. Or maybe along the way they found mistakes or defects again, so you have to do correction changes. Or maybe they change environment, they change to a new platform. Okay, so during maintenance testing, anything new or change, okay, let's say there are new defects found when the system is already deployed, you need to do confirmation testing. And to avoid any side effects due to the changes done, so you have to do regression testing. Okay, so that is done after the system is already been deployed at the user side. And if you want to do complete regression testing, it's too much, right? So what you do impact analysis. So you identify what might be um, you you do analysis first before you actually conduct the actual testing. Okay, so you see what might be the impact when you change some modules or different uh or you change any subsystem. Okay, because when you do this, you need to whenever you change any new functionality, so you need to know what are the modules being affected. So you need to scope down. You need to identify the scope. You want to see the size of existing system, size of changes, and the risk of change. Okay. Hopefully this information is useful for you. What you have seen so far is that you have looked at software development lifecycle. That is more like recapping what you have been using when you are developing system, and then we look at different test levels. Okay, which is related to component testing, integration testing, system testing, and acceptance testing. And then we take a look at test types, which is related to functional, non-functional testing. And then we take a look at maintenance, and there is another one, uh, whiteboard testing. Okay, so you can do different types of testing at different levels. And then maintenance testing is done when the system is already being deployed at the user side and they need to do modification on the system. Right, thank you so much.